Good day to you. You are welcome to Brainiac Serial College class. And the topic that we have here is under interpolation from numerical analysis. Given the following function values, x is equals to minus 1, 0, 1, 2, 3, and f of x is equals to 10, 2, 0, 10, and 62. Prepare the forward difference table. That's the first question. And the second question is using Gregory Newton's forward interpolating polynomial, find the value of f of minus 0.5. So now before we can actually solve the second question, that is the value of f of minus 0.5, using the Gregory Newton's forward interpolating polynomial, we must first create the forward difference table. Either they ask us or not, the first thing I will need to do is to create the forward difference table. And to create the forward difference table, the first thing I will need to have there is the x value followed by f of x. And as for the x values, the first one I will have there is -1, followed by 0, followed by 1, followed by 2, and the last one is 3. And as for the value of f of x, here we have 10. So here we have 10, then the next one is 2, and the next one is 0, then we have 10, then we have 62. Now, the first difference, that's delta f of x. So now, that will be, we'll get this one, change in f of x, we'll get it from this particular place. This is delta, capital change, that's change in f of x. So that will be 2 minus 10, which will give us minus 8. 0 minus 2, that will give us minus 2. 10 minus 0, that will give us 10. 62 minus 10, that will give us 52. We'll write it in between. So the next one will be delta square f of x. So now we can only stop here after finding the first difference if all the values are the same thing. If all the values that we have here are the same thing, after taking the difference, then we can stop there. But taking a look at all the values that we have here after the first difference, they are not the same value. They are not the same thing. So now the next thing is to obtain the second difference. That will be minus 2 minus minus 8. That will give us 6. Then 10 minus minus 2. That will give us 12. So just like this now, we have, that will be, the first one I will have here is minus 8 minus 2. Oh, sorry, that's minus 2 minus 8. That will give us minus 2 plus 8, which is 6. And the next one is 10 minus 2. That's 10 minus 2. That will give us 12. So now the next one is 52 minus 10, which will give us 42. So this one will give us 42. So now all the values that we have here, they are not the same thing. Then we'll go to the third difference, delta square f of x. So now that will be 12 minus 6. So that will give us 6. Taking the difference that we have here, this one will give us 6. 42 minus 12. So that will give us 30. So this one will give us 30. So now they are not the same thing. So we'll go to the fourth difference, delta raised power 4 of f of x. So that will be 30 minus 6. So this one will give us 24. So now this is the forward difference table for the function given. So now here we have x, we have f of x, delta f of x, delta square f of x, then we have delta raised power 3 f of x, then we have delta raised power 4 f of x. And the next thing I need to do here is to find the difference. And to find the difference for the particular question given, we'll get it from the f of x. If you are given a question under the forward difference table, say we have prepared the forward difference table. So this is the forward difference table. Forward difference table. And to prepare the forward difference table, we'll make use of f of x to get the change, the difference, one after the other. So now, since this one is 24, we cannot find any difference again, then we'll stop there. So now, going to the second question that we have here, to obtain f of minus 0.5, the formula will now be Pn of x is equals to the first value that we need to have there. We can use q. So we can use q from there, which is to evaluate this one, f of minus 0.5, we'll go to the table under the x value. Where can we actually get minus 0.5? So this would be s asterisk, which is equals to minus 0.5. And we can actually locate it in between minus 1 and 0. We cannot locate it here because this one is negative 0.5. And even is positive 0.5, then we need to get it between 0 and 1. That's 0 and positive 1. But since it is negative 0.5, we need to get it between negative 1 and 0. So here we need to have S asterisk here. S asterisk could be here. So which is between minus 1 and 0. Then we'll go like this. So this one is S asterisk. So we can locate 0.5 between this and this. 0.5 minus 0.5 is between minus 1 and 0. So now our S naught will be minus 1, F naught will be 10, then delta F naught will be minus 8. Delta raised power 2, F naught will be 6. Delta raised power 3, F naught will be 6. Then delta raised power 4, F naught, that will be 24. So I need to write all those values out one after the other. So here we need to have X naught, that's negative 1. Then the values that we have above this particular point, that's our X naught, which is minus 1. Then F naught, that's 10. Then delta F naught, that's minus 8. Then delta square F naught, that's 6. Then delta raised power 3 F naught, that's 6. Then delta raised power 4 F naught. Then that one will give us 24. And the next thing that we have here is we need to calculate the value of Q, which is S asterisk minus X naught over H. This H is called the mesh point. H, that's the mesh point, which is the distance between this and this. So we have H, that's the mesh point, the distance. So from here, the value of X asterisk, that's minus 0.5, and the value of X naught, that's negative 1. Then the value of H is 1. So from here, that would be negative 0.5 plus 1. So that will give us 0.5. So the value of Q is equal to 0.5. So we need to find the value of Q so that we can actually use it for the formula. Okay, so now the next thing is to write the formula that we need to use to evaluate it. That will be the one of the fourth degree. So I need to have P4 of X. That will be F naught plus P delta F naught plus, oh sorry, we are using Q, that's Q delta F naught plus Q into Q minus 1 delta square F naught over 2 factorial, then plus Q into Q minus 1, then we have Q minus 2, delta raised by 3 F naught, then we have over 3 factorial plus the last one will now be Q into Q minus 1, then we have Q minus 2, then we have Q minus 3, then we need to have delta raised by 4 F naught, everything over 4 factorial. So that's the formula. We need to stop at the fourth degree because here we have delta raised by 4 F of X. So it was not stated from the question, probably we should stop at the second degree or the third degree. So that is why we need to write the whole formula out to obtain the value of F of minus 0.5. So now from here, the value of Q is 0.5. The value of F naught, we have that one to be 10. So now the value of delta raised by 2 F naught, the value is there as well. So I need to have F of minus 0.5 is equals to the value of F naught, which is 10, plus, here I need to have 0.5 times the value of delta F naught, which is negative 8, plus, this one will be 0.5 in bracket 0.5 minus 1. Then delta raised by 2 F naught, the value of that one is 6. So over 2 factorial. Then we still have plus. So we still need to extend it. So we have plus 0.5 in bracket 0.5 minus 1, 0.5 minus 2. Then we are using this formula. So this is where we are. We are using this particular formula. So Q is 0.5, this Q is 0.5, then delta raised by 3 F naught, the value of that one is 6 as well. So the value of that one is 6. So we have 6. So everything over 3 factorial plus, this one will be 0.5 in bracket 0.5 minus 1, then 0.5 minus 2, then 0.5 minus 3, then delta raised by 4 F naught, that one is 24, then everything over 4 factorial. Okay, so don't forget that the value of q is equal to this. That's s asterisk minus s naught over h. So we need to find the value of q after getting this x naught, f naught, delta f naught from the table. So they ask us to evaluate f of minus 0.5. It is between these, and all the values that we have above the point, they are what we have here. So these are the points that we have here. So that's what we use to evaluate f of minus 0.5. Okay. Now the next one will now be, this one give us 10 plus, so we have 0.5 is here, times minus 8, plus this one is 0.5 in brackets, minus 0.5 times 6. 2 factorial will give us 2, plus 0.5 into minus 0.5. Then we have this one, that's minus 1.5, then times 6. 3 factorial, that's 3 times 2 times 1, that's 6. Then plus 0.5, then this one will give us minus 0.5 times minus 1.5 times minus 2.5 times 24. Then 4 factorial, that's 4 times 3, so that's 4 times 3, 4 times 3 times 2 times 1. So 4 times 3 is 12, times this one, that's 24. So everything is over 24. So now from what we have here, we'll now multiply it. So we can evaluate it using calculator. Then we have the first one I will have here is, here we have 10. 0.5 times minus 8, that's minus 4, plus, so we have 0.5 times 0.5 times 6. So this one gives us minus 1.5 over 2. Then the next one is 0.5. We have 0.5 times 1.5 times 6. So here we have 0.5 times minus 0.5 times minus 1.5 times 6. So 0.5 times minus 0.5 times 1.5 times 6. So that will give us 2.25. So we have, that will be positive 2.25, everything over 6. And the next one is, we have 0.5 times negative 0.5 times negative 1.5 times negative 2.5 times 24. So that will give us minus 22.5 minus 22.5, everything over 24, which is equals to, so that will give us 10. Here we have 10 minus 4, then minus 1.5 divided by 2. So this one will give us 0.75. Then we have plus 2.25 divided by 6. So over 6, that will give us 0.375. Then minus 22.5 divided by 24. So that will give us minus 0.9375. So then we add everything up. That will be 10 minus 4 minus 0.75 plus 0.375, then minus 0.9375. So that's 4 points. So this implies, therefore, f of minus 0.5 is equals to 4.6875. So that is the final answer. So the first question says we should create the 4 difference table. So we should prepare the 4 difference table. So this is the 4 difference table. And again, the second question says we should evaluate f of minus 0.5, and the value of that one is 4.6875. And the formula to do that, that is what we have there. We stop at the 4th degree. So it was not stated in the question, probably we should stop at the 2nd or 3rd degree. So we're going to use the whole formula like this. And to get the value of q, don't forget that the value of q is equal to s asterisk minus x naught over h. And this h is the mesh point. So you obtain that one from the x values by checking the difference between this, and that's 0 minus this, minus 1, 1 minus 0, then 2 minus 1, then 3 minus 2. And the difference is what? They are all the same thing. They have the same mesh point. So if the mesh points are not the same thing, that's when we'll now use another interpolating formula, which is Lagrangian interpolating polynomial formula. Kindly like this video, share, and follow for more.